with the back of the patient. So what pathogen do you think is the culprit here? So please continue to, if you post a pathogen, you can indicate your reason. So this is a patient who reported to clinic in Japan after traveling back to the country from Tahiti in 2014. They did not have a fever. They had this conjunctival injection or some form of the conjunctivitis. And a generalized purpuric rash on the body, as you can see from the back on the second panel. So I can see a few comments in the chat. Zika from Christopher, Chepkorir from Marburg. Christopher, I would like to know why you think it's Zika. Harrison, adenovirus, saying because of conjunctivitis. Adenovirus would most likely cause by a bit more edematous conjunctivitis, but it's possible. Marburg presents with red eyes and maculopapular rash. Okay. Parvovirus, interesting. Somebody's asking what the topic is. Zika virus because of conjunctivitis and rash. I think it's Zika. Okay. So I think this is enough waiting. We can start now. We'll get back to this patient later in the presentation and see what might be the cause. But again, this highlights the challenges that you have with pathogen diagnosis. As you know, the emerging and re-emerging pathogens, as you've seen in the past, will not always announce themselves with a megaphone when they knock upon you as a clinician. You may be just treating your next patient only to later realize that that person is the first Ebola patient in Kenya or has a new pathogen that you've never heard about. So the idea is to remain vigilant, because at that time, when you realize too late, you might be already infected and have infected your family or the people you live with and your other patients or colleagues. So keep your gear, your protective gear on at all times, and assume every patient can infect you with something. The outline of today's presentation on emerging and re-emerging infections will help us define or describe them. What are they? We will also discuss the significance. Why are they important? Why are we taking about 2 hours to talk about them? And what are the factors associated with the emergence and re-emergence of diseases, especially infectious diseases? We'll talk about a few case studies, Zika, SARS, and Ebola. We'll also talk about diagnosis general of emerging infections, not focusing on one specific one, management and prevention. So in terms of description, we describe emerging infections as infections whose incidence has increased in the recent past. Usually some people quote 20 years. I don't think there's a general consensus, but that's conventional, and could also increase in the near future. So you're thinking of diseases which have been newly identified, and there's a risk that they could, the incidence could increase in the near future. the important thing here is that they had not occurred before in humans, at least before these 20 years. So at some point, you can imagine every disease was emerging. HIV was emerging at some point. It could have fitted that description until 2000. Many infections would be in this category initially, but after 20 years, then they can go into the next category, which is re-emerging infections, where infections that have declined but are now posing a significant threat to public health, or they were just non-significant and now they are growing. So either we thought we had controlled them, but they are resurging, or they were fairly a non-issue. If, for example, we mention a virus like Mayaro virus, which I mean, that is already an issue. So maybe a virus that does not really cause a lot of problems currently, maybe it's restricted to one area. And then over time, you begin to see it in other places, geographical regions. So, and this has occurred with very many viruses. I will show you an example with Zika, but also chikungunya had been restricted to Africa for a long time, until 2000, the mid-noughties basically, where there was a large outbreak in Lamu, where nearly everybody in Lamu was infected. I think the antibody prevalence, their seroprevalence was about 70%. And then it spread to the Indian Ocean Islands, Reunion, and the rest all the way to India. And it was realized at that point that it had mutated to infect a new vector, a new species of Aedes mosquito, which has a bigger or a larger geographical cover. It's called Aedes albopictus. We will cover this in entomology. So because of that, it's now managed to spread to all the other continents, maybe except Antarctica. So there is a lot in terms of geographical spread that can change these pathogens. And this could also occur in a new population. An example here is Zika, which was previously like dengue, but then in 2014 or thereabouts, 2015, 2016, in Brazil, it was causing a lot of havoc in fetuses or in newborn babies, but mainly through fetal infections. We also have a good example here being HIV, which was causing, when it emerged, it was causing people, because of immunosuppression, people who are previously healthy and young, to get things like Kaposi, sarcoma, and PCP pneumonia, which is an atypical pneumonia that was previously seen in people who are immunosuppressed. So these were new populations that were being affected by diseases that had been around for a while, and also causing new manifestations. Again, a good example here is the influenza, which in 2009 started to cause gastrointestinal manifestations. Zika in 2015 again was causing some CNS manifestations which had not been seen before. So this is the thing about infectious diseases. It's like now COVID, which we know to cause quite a number of manifestations, reinventing itself or undergoing mutations and beginning to cause signs that we did not expect before, say paralysis or something, and then it would be a re-emerging infection. Why the concern? There are many reasons why we are worried about emerging infections, and at least you guys have seen a real life experience. If I was teaching this in 2019, it would sound very abstract, but we see the mortality and morbidity that is associated with COVID-19 and other emerging infections. The economic losses are in the billions. You saw in our own country and across the globe how many businesses had to close, how many people lost their jobs. And even this had a lot of social impact. People were supposed to travel to places, to do exams, to attend weddings, to see their grandmother, were not able to do that. Families were separated, and some families that are not been used to living together, maybe a guy had been married and the wife was staying away, working away, and they only met once a month, were now locked together for months. And so the social impact was very interesting. Public anxiety and public panic, you saw that. So initially COVID came, a lot of Kenyans were pushing the government to take action in all manner of ways, even those of us who are not expert in this area. This is because of that panic and anxiety. And right now, even when COVID is around, the anxiety seems to have gone. A lot of people now have adjusted to that. But now there's anxiety around Ebola and maybe what is the next, like monkeypox, for instance. So this kind of pathogens that people have not encountered yet tend to cause more anxiety and panic. The unpredictability also becomes a challenge because you are to prepare for a disease that you cannot fully predict. So we need to be ready for the next emerging pathogen or emerging pathogen, but we do not know what it is. We do not know where or how it will start. And so that unpredictability makes us, puts us in a situation where we have to take measures, some of which we may never apply, but just to be ready. And then the mystery of where does this virus or pathogen come from? You saw the issue of whether COVID-19 came from a lab or came from a bat or a pangolin or whatever it is, taking a very big chunk of our discussions and even causing people to question everything else that was associated with COVID-19. Yet we know, at least if we're in a hospital, that COVID-19 was real, it was infecting patients and killing some of them. How is it transmitted? Yes, right now, a few months ago, we had a discussion on whether monkeypox is sexually transmitted or just through direct contact. So these kind of questions make it difficult to fashion public health messaging and even interventions, because we are not very sure of how certain pathogens that may be new or re-emerging, how they are transmitted, which routes, and how easily they are transmitted. Now, disease emergence follows several steps, and many of times it's abortive. It may not succeed. Many times because of species restrictions, evolutionary restrictions, ecological restrictions, we have a lot of restrictions. So by the time our disease is emerging, it has jumped a lot of hoops. This chart here is showing the number of cases on the vertical axis and time, which is not really specific, on the horizontal axis. If you start on the left, you can see the initial wavy-like curve, which is showing low-level circulation of an infection, say an infection like monkeypox, for example, which is the reservoir would probably be a rodent, and because the rodents are closely related to the monkeys and other primates and bats, it may be causing low-level circulation in those animals as well. And then that is not noticed by us. So as human beings, you will not realize unless you are really careful and you are dealing with these animals that there is an outbreak. So once in a while, it will go down, it will go up. And this can be affected by several things. For example, imagine you have some rodents living in a certain area of the national park, and they have this disease circulating there for many years, so they are relatively new. And then you decide to construct a road across that park. What happens is that you displace a population of animals that then goes to another part of the park or to even another part of the city where it will interact with new populations. The new populations could be other animals, or it could be human beings. But the new population has not been exposed to this pathogen before. So what we have in that population? Susceptibility. The new population is susceptible, so the cases might go up because the new population has now been exposed to a new pathogen. I hope you've heard about the stories of when the so-called European conquerors were going to colonize the Western Hemisphere. The original or the Native Americans who are living in those places had a lot of issues with the new infections like smallpox, wiping out nearly 90% of the population just because they were susceptible. That is the impact of introducing a new pathogen in a population that is not been exposed to it before. But anyway, in this situation, you have low-level circulation. And then for some reason, there's a spillover from these wild animals to domestic animals. These are the animals that are either going into the forest or the areas around the forest for food, for foraging. And so there's a bit of interaction, either directly or indirectly, with the wild animals. This could be through direct contact or through vectors, such as these ticks and mosquitoes and other fleas and whatnot. So that spillover will lead to a spike in cases. And you can see this spike is because you have introduced the virus or the pathogen in a new population. And at this point, if you're careful, you'll be able to notice it. And this is where One Health comes in, that you notice either your cows are having a lot of diarrhea, or they're dying, or they're having lesions, or even abortions in these cattle. And so if we take it seriously at that point and we take the samples and test them, we may be able to detect the pathogen at this point. Then if that is missed, the virus or the pathogen will be amplified because now the population is larger. So the amplification is because you have very many hosts that are susceptible. When they get infected, the more they get infected, the better for the virus or the pathogen, because it gets a chance to infect more people, mutate, and in the process, it may cross over to humans. At each of these species, there are evolutionary or genetic restrictions. For example, COVID-19 is thought to have jumped from a bat into a pangolin and then into a human. And at all those junctions, it needed to undergo some mutation so that the receptor spike, like the viral spike protein, can be able to bind, for example, the human ACE2 receptor. If the virus is not able to bind the human receptors, even if a human being is infected by accident, that human being may not be able to infect others. And that happens sometimes with influenza, some types of influenza which cross over from chicken or pigs into humans, but they are very poor at infecting other humans. So the first human is infected because of the high dose exposure, but because they are not able to infect others, the disease, it tends to be limited. So all these spillovers don't just happen all the time. There are restrictions there by species differences. But if it gets into humans, you can see there will be a sharp spike, and this is what we tend to detect. If it's not so high, sometimes we miss it, but this is what we tend to detect. But you can see by the time you are detecting an outbreak in humans, it has been ongoing for a long time in the forest, in the should we say the periforest area where you have your cattle and other domestic animals. So it means if we can take additional measures to detect it before, then we'll not have this problem in humans where we get people getting infected and dying from these diseases. And you'll see why it is important to focus on this, because the majority of emerging infections actually come from animals. Not all of them, but a majority of them. So that is it describes disease emergence. You can see here by numbers, and this is from the Africa CDC, you have, out of all existing infectious diseases in humans, 2/3 are from animals, or they can be shared with animals. They are zoonotic. Out of all emerging infections in humans, 75% are from animals. So like you can see already, monkeypox and COVID-19 in the last 3 years, which have been the major issues. There are others, of course, like influenza, Ebola. They are all from animals. In terms of bioterrorism, all the agents that we are concerned about in terms of bioterrorism, 4/5 or 80% are also of animal origin or zoonotic. And every year we have an average of about 5 new diseases. 3 out of those have an animal origin. So for that reason, we need to be careful, or we need to care and take measures how we interact with animals, not of course to eliminate them. We can't do that. It's not good for the planet anyway, but to be healthy, both the environment, the animals, and us, and to be ready and prepared when these pathogens cross over, because we'll not stop them. Once in a while, they'll always cross. The question is, how soon do you detect them, and how soon can you contain such an emerging pathogen? As I said, we'll be talking about things that you have done before. This is just a quick reminder of when you talked about arboviruses, you may have talked about these cycles where you have a sylvatic cycle in the forest between mammals and mosquitoes, usually non-human primates for yellow fever. And this can cross over to the savanna or the rural areas where there's an interface between the forest and the human settlements, and fewer people as compared to the urban areas. And so in the savanna, there'll be circulation between man and primate, and eventually it will cross over to the urban centers where the virus no longer requires animals to be maintained in circulation. In this instance, there will always be a human being who is infected. So all you need is a competent mosquito to transmit it to the next human being. And over time, it becomes endemic. The only times you notice is when the mosquitoes abound, or there are so many that transmission becomes more efficient. And so you see the number of people presenting with the cases becoming many. So at that point you realize, oh, we have an outbreak. But really, most likely it is being maintained in circulation just from man to man by a low-level number of mosquitoes. But once in a while, when there's a large number of mosquitoes, then it may become a problem. And this is not just for yellow fever, it happens for many other viruses today. And you can see that cycle coming from the environment to the forest environment, the rural environment, to the urban environment. All these play a role in this emergence of pathogens. I'm just looking at your comments now. Somebody wondering whether camel is a domestic animal. Yes, it is. It is actually one of the most important animals in northern Kenya because of the value and the ability to withstand harsh conditions. There are many countries now that rely on camels for many things, including milk and meat and hide. And in the Middle East, they're actually treated as pets. And so people tend to interact with them more closely. So you need to educate yourself a bit about camels. They're also very interesting because their antibodies have one arm, so they are very narrow. They can easily penetrate tissue. And somebody has tried to modify that to use them for local administration after snake bites. So camels are interesting. You should take a look at them if you have never met one. We see disease emergence along this continuum where the virus is living within a reservoir host in the forest, for example. Let's say a bat or a rodent. And then it jumps. And when we say jumps, this is a process that can take a lot of effort, a lot of exposure, re-exposure, mutations, and eventually it's able to colonize a new host who could be the intermediate host. Say for example, if it's a monkeypox from a rodent, it jumps to monkeys. And then within that new population, because of closer interaction with humans, you have individual or breakthrough transmissions to humans that do not really do much because the virus at this point may not be very efficient at infecting humans. It's still adapting, it's still mutating, so it may not be very efficient. And then over time, it may be able to efficiently infect humans. And so we say there's a cross-species transfer. And this is the narrow point. This is the bottleneck. Once the virus overcomes this bottleneck, like COVID did, and it's able now to bind and easily attach to human cells, then you will begin to see sustained human transmissions at different levels. It could start with short human-to-human transmission chains, where say somebody got infected by avian influenza at a farm in Kitengela. They infect 2 or 3 members of their family, and the virus dies off because it's still not very efficient. Or you can have restricted outbreaks where a few people outside that circle are also affected. And eventually, it may cause prolonged human-to-human transmission where the virus has now been able to be sustained within the population for a long period. Like monkeypox now, we can say for a long time, it was undergoing human-to-human transmissions for years, for decades, before it caused the pandemic we are seeing today. So that level of emergence can occur over time, or it can occur very fast. You saw, especially for COVID-19, after crossing the species barrier, it was able to quickly move from few or short human transmission chains to pandemic level within a few weeks. So that is the difference is probably because of the route of transmission and also the efficiency of the virus in infecting humans. There are several factors that are associated with fueling emergence and the emergence of infections. One that we all know very well is economic activities. We undertake economic activities in or around forests, be it logging. Irrigation also exposes us to many pathogens, including vectors of pathogens like mosquitoes and snails. You learn about snails next year in parasitology. Animal husbandry, the people taking care of hundreds of chicken or even hundreds of thousands of chicken in farms, and pigs and other animals that we take care of are at risk of some of these viruses. Climate change is interesting. I would like you to think through this. Maybe you can tell me how you think climate change affects our health. International travel and trade also makes it very easy to infect people. If today somebody gets cholera in Nairobi, they can travel to Guangzhou or to Amsterdam and within the day and get sick there tomorrow and maybe expose other people. So that that ease of travel is very important for disease spread. 100 years ago, when your grandfather was traveling from Kericho to Nairobi, if they got cholera along the way, they would never get to Nairobi unless they get treated, because the distance is long, there is no formal transportation, they have to use other things that may not necessarily be fast enough to get to Nairobi. So this is an important part of infection. We've had cases of mosquitoes riding on used car tires being exported, say, from India to Brazil. And so they will carry dengue with them and other pathogens. So that is a very key push for these emerging infections. Immunosuppression allows pathogens that were initially, okay, not pathogens, viruses and other organisms that were not pathogenic to now cause disease in humans who are immunosuppressed. It could be HIV, it could be cancer, it could be immunosuppressive illness for other reasons, and also pathogen evolution. And we are still getting to understand this, but if you've heard about antimicrobial resistance, it's driven by pathogen evolution. As somebody is exposed to antibiotics, they will, or the bacteria will mutate, or even the virus will mutate, and it will form a new strain that is resistant to those drugs. The other example I gave you is for chikungunya, which mutated in the mid-noughties to infect a new pathogen or thrive in it, for not pathogen, host. The main pathogen, the main host for chikungunya previously had been Aedes aegypti, but it was able now to survive very well within Aedes albopictus. And so, because Aedes albopictus, the newer vector, has a larger geographical spread that allowed chikungunya to spread further. There is also the adaptation to new host range, like we've seen with the COVID-19 or SARS-CoV-2, and generally the story of most pathogens that cross over to humans. So pathogen evolution is harder to see, but it's important part of this game. There are also weak public health systems. In 2014, I think, when the largest Ebola outbreak in history occurred, the virus had been circulating for at least 3 months in Guinea before it was detected. By the time it was detected, it already spread across the region. So you can imagine 3 months of waiting instead of controlling. In Uganda, it was about a week. Within a week, people had realized it was Ebola. So that helps with the response. Weak public health systems means people will go to a hospital, and what we do in Kenya, you go to hospital with a fever, unapimwa H. pylori or salmonella, typhoid, which really don't mean much. Somebody ends up getting antibiotics which they don't need. They come back a week later, or maybe they don't. In the meantime, they'll be infecting other people. Those other people present to other facilities. They may get the same treatment. By the time we are getting somebody or a system, a facility that can diagnose the problem or detect the problem, a lot of people, including healthcare workers, are already infected. So this means that we need to think about the farthest facility and make sure they are sufficiently trained and have the capacity to test for the right things or collect samples and send them to the referral labs where they can be tested. And also be able to monitor information quickly so that you can know when there's an unusual number of cases with diarrhea or an unusually high number of cases with fever and so on. Because that indicates that there could be an outbreak. Poverty and social inequality are a big issue. We know poverty is associated with a lot of these problems because of many issues. Civil unrest and war. You can imagine right now in Ukraine, how many children are getting vaccinated. In Yemen, in Syria, which have been at war for more than 10 years. These are places where the health takes a backseat. And so even diseases that have been eradicated become an issue. You can remember the issue we had with Somalia and polio, even with Boko Haram in northeastern Nigeria, in Afghanistan, there were issues with polio that have not fully been settled to date because of war. Bioterrorism is another concern, and there were cases in the early 2000s where somebody tried to use anthrax to infect people in the US. So people, it is always feared that people may try to fashion a pathogen and use it for bioterrorism. It's more of a fear than a practical thing. Not very many people have tried it, but we're always ready or preparing for it. Illiteracy and lack of awareness is a big thing. Now there is also, we should add here, misinformation and fake news. So this can sometimes fuel diseases and or disease emergence. And it's a big challenge today where information has been democratized by social media so that it's not the person with the correct information that is heard, but the person who speaks loudest. Human behaviors like recreational activities, drug use, sexual habits are also linked to this. We have a lot of people going hiking into caves and other places where they get in touch with other animal populations. We have people who abuse drugs and mix this with the unprotected sex with very extreme habits that may increase the risk of transmissions. One good example here is hepatitis A, which is transmitted fecal-orally, but where anal and oral sex are occurring together, we've seen cases of hepatitis A being transmitted. So there are many factors, but the if I was to select three, I would talk about globalization, climate change, and international travel and trade. All these have contributed to transmission of emerging infections. So this is a point at which I'm going to look at the chart, and as I look at the chart, please read the question on the screen. What is the impact of climate change on infectious diseases? I would like to hear your thoughts. How do you think climate change is affecting? I'm assuming you already know what climate change is. How do you think it's affecting our infectious diseases? I'm looking at your comments. When I see something worth responding to, I will respond. I can see guys really need to interact more closely with camels. They're very nice animals. I've done one of my research studies on camels, and we were drawing blood from them to test for MERS-CoV. And they were generally very, very patient animals. So now I'm reading your comments on climate change. I think climate change fuels emerging and emerging infections by making an environment more conducive for spread of a virus, e.g. warm area, climate change to become cooler, that may enhance infectivity. Yeah, that is true. Climate change generally will cause extremes of temperatures. Where places are hot, they may become hotter. Where places are cold, they may become colder. Rain becomes sparse, and when it rains, it pours, so it floods. And all this cause extremes of weather. And that alone, of course, will cause problems. If there's a flood, you know, things like cholera will emerge because our water will mix with the sewage and whatnot. But also vectors of diseases, things like mosquitoes will abound in such situations. Let me see if there are other comments here. I don't know why you guys are sending me direct messages instead of sending everyone. It's better when everybody can read. Climate change, this is by Omondi. Climates are featured with increased vectors, Aedes albopictus, that is true. Rising temperature in countries may cause increased spread of vectors, extreme floods. Okay, so you guys have an idea. Let's look at a graphical presentation here of some of the issues you need to be aware. And how do we explain climate change in a simple way? We are producing a lot of greenhouse gases. This is mainly CO2, but there are also others like methane and nitrous oxides, which basically reflect or act like a blanket, so to speak, that keeps the earth warmer. And because of that, we have an effect on many things, from water to weather to animals and plants. And if we are to look at the 5 things down here, air quality, which means things like dust and water view causing problems with breathing and other lung diseases. Food and water security, which is important, because if you are in drought or in floods, you lose food, you cannot have your income, and we know food and income are related to malnutrition, and that is related to health. If somebody has gone, for example, in North Horr, which is a very vast part of this country, traveled 100 kilometers to look for pasture, and they get sick, they will not be able to access a hospital. There is none nearby. And diseases are the main focus today. And this, we have vectors, for example, expanding their habitats outside the tropics, further north and south. And warmer temperatures make vectors more efficient at transmission, because first of all, they are able to live shorter cycles. They're able to basically reproduce more. And the viruses are also able to multiply in these higher temperatures faster. On top of that, of course, there are other things like extreme heat and weather. We have a lot of people dying from heat exhaustion and floods, and also people who are dying from the social impacts of this. If a few months ago I was in southern Ethiopia, and because of drought, people were already moving from the areas where they live in, where the government has provided facilities, to the road, because wherever they have been living has been so dry, there's no food, so they come to the road and get tents. There are no health services there. When people are living in such community areas with new people, there tends to be more crime, especially risk to children and women. And there's generally a bigger social impact when there's disruption of people moving. We have climate refugees of people moving, even within our country, to different parts. They don't move with the services. They don't move with the school. They don't move with the hospital. They do not move with a lot of their amenities, and that causes a lot of impact. And all this exposes people to different health challenges. And they are also not able to withstand a new infection. So when they are hit with a new infection, their immune system is not robust enough at that point because of malnutrition and a lot of other stressors to withstand that new infection. So there's a lot we need to educate ourselves on climate change. And the evidence is there. If any of you are doubters, you look for it, you'll find it. Examples of viral emerging infections are many. This is not even a list that can be said to be halfway complete. I'm just mentioning those that you may have heard about. And here I'm talking about both emerging and re-emerging infections, from flaviviruses like dengue and yellow fever and Zika, to alpha viruses like chikungunya, onyongnyong, mayaro, Sindbis, filoviruses or filoviruses, depending on what term you like Ebola and Marburg, which now we are all familiar with. Coronaviruses don't need an introduction. We've had SARS in 2002, MERS-CoV in the Middle East in 2014 and 2013, and now SARS-CoV, which is currently an ongoing issue. Bunya viruses are many. Actually, the one that I need to include here as a matter of importance is RVF, or Rift Valley fever. Bunya virus is actually now not a family. They are an order. The families, 10 other families have been created within this, but I prefer to use it because then I love to list all the other 10 families, which I don't have space for. But you've heard of Crimean Congo, hemorrhagic fever virus. You've heard of hantavirus. You've heard of Rift Valley fever. These are viruses that keep causing us trouble. We've looked at some animal data with KWS, and Crimean Congo antibodies were very prevalent. So it could be circulating, but has not been crossing much into humans. Unfortunately, we don't have very good assays to look at this in humans, but it's something we're trying to look at so that we define how big a problem it is. Orthomyxoviruses is mainly influenza here, and we've discussed influenza, so I don't need to describe it more. You may have heard of Nipah virus. It's been a problem in India a couple of times. And measles. And measles is interesting because it's one of those viruses that does not have an animal host. We have a vaccine for that works very well, but many times people will come and say, measles vaccine caused this or the other, so we will not take our kids. And over time, these anti-vaxxers create a population of people who are susceptible, and that creates an opportunity for emergence of disease. Because measles is so infectious, anytime you introduce it in a population where a large number of people are susceptible, it will cause an outbreak. Then we also have rabies, which has been, the focus now has been on vaccinating dogs actually to try and eliminate it. Many countries that have done that have eliminated it, at least dog rabies, but we still have circulation in other animals. So keep your mind open. These are not the only viruses you'll hear about. There are many others. You can see here I didn't include pox viruses, like monkeypox. There are many others that will fit this category. Now, this slide is not for you to cram the first 9 diseases. It's for you to notice one thing. Created in 2015, there is a disease we call disease X or pathogen X. What is it? Yes, there are many, and you can see most of these are viruses, if not all. But what is this disease X? And this was in 2015. I put it here so that it can be clearly before COVID. And really what WHO was trying, or the scientists at WHO are trying to communicate here, is that we may list all these pathogens, but there's always that potential or possibility of a new pathogen that we do not know emerging and causing problems. And that is what happened in 2019, 2020 with SARS-CoV-2. So the question is, how do we prepare then for disease X? How do we prepare for this disease that we do not know, or this pathogen X, which can be a fungus, can be a bacteria, can be a parasite, can be a virus? How do we prepare for it? Now, transmission of emerging viruses is also as broad as the pathogens. It could be through arthropods, like mosquitoes. You will learn a lot about this next year with Dr. Mukoko. They could be vertebrate vectors, like rodents and bats. Some people don't consider these vectors. You can call them small mammals, although primates are not necessarily small. But yes, these mammals that can cause, and usually they are the most diverse. Bats and rodents are the most diverse mammals, the very different types. Rodents and bats carry very many viruses that don't seem to cause them a lot of trouble. When they cross over to primates and humans, sometimes they cause trouble. Direct contact, we saw this with monkeypox, for instance. Vertical transmission, we've seen this with many viruses from our fashion so far. The sexual intercourse as well. We've seen things like Ebola in being transmitted from especially men to women, and also because there's a lot of it in semen, and also Zika. And now we've seen an element of this with monkeypox. Inhalation, like with SARS-CoV-2, ingestion or eating contaminated food or water. So there are many routes, and this is just to show you the general approach you need to have when you're looking at Aedes. Don't just keep your mind locked to one thing. It could really be any of these pathogens, any of these routes. There are many vectors. I've listed mosquitoes here for completeness sake, so that, actually, for example, sake, because there are many others that we didn't list. The commonest mosquito that I'm worried about as a virologist is Aedes mosquito. It transmits very many viruses. You can see from most flaviviruses, not all. Alpha viruses like chikungunya, some alpha viruses are also transmitted by Anopheles, and also Bunya viruses like Rift Valley fever. So you can see the transmission. And there's a point of note here that Rift Valley fever among humans is actually transmission may be different. But the idea here is that these mosquitoes can transmit very many viruses. Anopheles has a shorter list. You just put one here as an example. Nyong Nyong. Culex also has a shorter list, a bit of flaviviruses like West Nile and alpha viruses like Eastern equine encephalitis. But you can see the vectors have also different distributions. In Nairobi, for instance, we have a lot of Culex mosquitoes, not so many Aedes and not so many Anopheles. In Mombasa, we have both, if not all. In Kisumu, a lot of Anopheles and a bit of Aedes. So the diseases to be transmitted, or the disease for you to consider as important in an area will also be determined by the vectors that are there. We also have ticks that are known to transmit things like tick-borne encephalitis, Crimean Congo hemorrhagic fever, and Colorado tick fever, among others, all in different families. And then phlebotomy in sandflies, mostly important in parasitology, but they also transmit a few viruses, like the sandfly fever in the Mediterranean, and a few other viruses in that area. There's also a lot of sandflies in Kenya. So, but these in Kenya, they're associated with leishmaniasis, which we will learn about next year, which is not a viral infection. Now, if you look at this image, it's very easy to distinguish these mosquitoes. So if you catch them, please check. Last year, I'm very interested in the Aedes groups. And last year, some of the medical students helped to identify Aedes in Chiromo, where they were studying or living. So if you see them anywhere in Nairobi, please take a photo and share with me. You can see the differences. The Culex is very brown. The Aedes will have black and white spots, looks like a zebra. And if it's a male, you can differentiate, but that's not important for you now, but you can see it as a very hairy papilla. It will still have very distinct species markers like this brown Culex and this zebra-like Aedes. I'm more interested in this species, Aedes, or genus Aedes, because they are transmitting viruses. I spent a lot of time in Kibera in 2017 looking for mosquitoes, and I only caught one Aedes. And I caught thousands of mosquitoes with my team. Most of them were Culex, because the Culex in Nairobi is fond of polluted water. And so it multiplies very well in polluted water. Aedes tends to be more of a forest mosquito. So if you're in Chiromo and other forested areas, it's possible to find it. Anopheles prefers less polluted waters. And that's why in Nairobi, we don't have such a big problem with malaria, because most of our pools of waters are polluted. Now, vertebrate agents can also transmit diseases, and these are bats, rodents, camels, birds, dogs, and even cattle, and all this can transmit. And just again listing to open up your minds to know that you can get different things from different animals. From bats, you can get Ebola, Marburg, and there's also associated with rabies. Rodents can transmit rabies, Nipah, and hantaviruses. Camels have been known to transmit MERS-CoV to human beings. In our study in northern Kenya, and actually not northern Kenya only, we started with Baringo, went round to Turkana all the way to Garissa and Makueni. So passing through Marsabit, Mandera, Wajir, and we found nearly 80% of many of these camels were exposed to MERS-CoV, but they were very healthy. They had the antibodies, but not the virus. So it means they had been exposed, but they had not gotten very sick because they were still alive and they were okay. The question is then, how many humans were infected with MERS-CoV? And we tested what we call the camel handlers, the people who were taking care of the camels, and not very many of them had the virus. Very few had this, I think very small percentage. So it's an interesting interaction, and it still continues to cause us a concern, for example, if MERS-CoV could emerge in Kenya. And we know camels, as I said, are all over the place. They are a big, I think the biggest country, the country with the biggest camel population is Somalia. But countries like Australia actually have wild camels roaming the desert. And the Middle East also imports a lot of camels from the Horn of Africa. So we have a big opportunity for interaction with humans. The birds are also very interesting because they migrate. Birds will migrate from Siberia, from Finland in the north, all the way to Cape Town in South Africa, sometimes as far south as New Zealand, using different routes. And they can carry these viruses, and everywhere along the route they have what we call resting points or roosting zones where they rest. You may find pockets of infection with different viruses that are being carried on these birds. So it's important again to keep that in mind. If you're working somewhere and you notice a lot of bird deaths or birds just dropping dead, then you need to take some measures and find out what is causing that death without exposing yourself. This is to show you that there are different challenges in different parts of the world. This is in DRC Congo. Everybody in DRC Congo, Cameroon, and most of West Africa loves game meat. 99.5% will have tested the form of the other. And you can see dressing these animals, cutting them up and dressing them, puts at risk the people who are dressing them. This is in Ghana. As you can see, very similar picture. This is in Indonesia. Different animals, same purpose. Some will be used for rituals, some will be used as pets, some will be used for meat, for food. I understand the python is very fleshy, it has very nice meat. I haven't come across it yet. Indonesia, again, you can see different animals. This is in Kenya, live chicken market. Just before you start judging other communities with a lot of self-righteousness, you also commit these cultural practices. So this is to show you that our exposure and our interaction with animals occur every day. So how then do we get prepared to make sure that when a disease will cross over, because given these situations, you will not stop people from eating chicken. You will not stop people from eating the other game. You can try, but you will not. And so how do you stay ahead of the emerging infections? It's very easy to say, oh, we should stop eating bats. Oh, we should stop eating rats. Oh, we should stop eating this or the other. But it's not easy. It's like stopping Kenyans from eating ugali, even when the price of ugali is 3 times the normal price. Yet we know there's potatoes and rice and bananas that would make a good option. So some case studies. This, for you not to cram, is just to create a mental picture. I will not ask you to tell me how many people died of SARS in April 2003. That is not very good use of your brain power. But you can see the pattern. For example, with SARS-1, November 2002, somebody noticed a highly contagious, severe atypical pneumonia in southern China. This was at a hospital. In February the following year, there was a spread to Hong Kong, which is nearby, by a doctor who later died. And within a few months after that, WHO issued a global alert for this atypical pneumonia. At the time, we didn't know the virus very well. It was taking longer to study them because we didn't have the tools that we have now. In 2003, Hong Kong University and CDC identified the virus as a novel coronavirus. Previously, we only knew the 4 coronaviruses that cause common colds. This was the first SARS. We had not even known about MERS-CoV-2 and SARS-CoV-2, MERS-CoV and SARS-CoV-2. By April 2003, this was how many months? 8 months later, we got our first full genome. This is the first full genome published of SARS. You can see a very long time. And it's from this period that then people can begin to research on vaccines, on PCR and other diagnostic tests, on other antigen tests, because you now have a genome that is reliable. Otherwise, before this, it's very difficult. Now with SARS, with SARS-CoV-2 or with COVID-19, this process took a week. From identifying the pathogen and getting the sequence took a week, not even less. Identifying that there's a problem and then sequencing it was very quick. And by December 2003, the virus had spread to nearly 30 countries, 8,000 cases, with 10% of those dying. And initially we thought, and we blamed, a lot of people in China at the time blamed civets, which are these cat-like mammals, and they were thought to be the natural hosts, and a lot of them were eliminated at the time. But later, it was realized that it was actually bats that were the reservoirs, which had then probably gone through civets or just infected this by chance. You can see the spread here at the time, Africa being the dark continent at the time, we didn't get any cases, mainly because there was not very much travel with the rest of the world. And you can see Australia, Russia, Europe, Central and North, and also Western, US, and thousands of cases later, we we were able to say there are no more transmissions. And since then, we've not had issue with SARS-CoV, but it was used to do a lot of research, and that helped for people to prepare better for SARS-CoV and also for COVID-19. The impact of SARS was big at the time. You can see 10% of deaths is not small. COVID-19 right now is about 1.5%. And actually 29 countries affected. Airline passengers dropped markedly. I'll show you an image here. You can see, you can't imagine an airport looking like this. Tourism dropped, economic losses were in the billions of dollars. Of course, COVID-19 multiplied this hundreds, if not thousands of times, actually thousands of times. But at the time, SARS-CoV was a major issue. Zika was another one. Initially, it was isolated in a forest called Zika near Kampala in Uganda, in monkeys. And then there were initial first human cases reported in Uganda, Tanzania, and Nigeria. And it is actually categorized into two lineages, African and Asian, because earlier on it was able to cross to Asia. And it had an exotic cycle of transmission initially, but then it's crossed over into humans and was able to maintain a human-to-human transmission cycle, the urban cycle, as we call it. So you can see here in the 50s and later in the 70s, it was circulating in Africa. Then it crossed over in the 70s to India and the environments around India, Southeast Asia. Then Micronesia, which are several islands in this area, which you can't see in this map because they're too small. And a lot of people go there for holiday. Tahiti is one of those places where people, the French Polynesia, where people also go for holiday. Then it crossed over from, it's like going around the world, Brazil, where it became a big issue. At this point, it was affecting hundreds of thousands of people, causing manifestations that have not been reported before, like microcephaly in babies that have been infected in utero. So this is showing you the evolution of this virus. Later it went around from Brazil to Cabo Verde, which is Portuguese speaking. So you can see the link with Brazil, and also later the Maldives because of the holiday element. And this is the picture I started with initially. I bet those of you who say this was Zika had probably seen it before. I don't think I would have said this is Zika as my first diagnosis if I didn't know it was. This is showing you the non-specificity of the symptoms that emerging infections will present with. It could be something you've never seen, it could be, but most often it will be something you've seen or something that looks like something else. So you really can't tell unless you look for the patterns, for the history, for the risk factors, and then you test with a reliable lab test. So this was a patient that I started with. The complications of Zika that came in at this point were mainly in fetus, in children who had been infected in utero. And these were countries, remember, in South America, which really do not condone abortions because of their Catholic faith. So it was, physicians were at a crossroad. What do you tell a mother who has Zika and is carrying a baby? And we saw different innovations to try and help these mothers, but it is always a challenge. So some social issues that we hold dear to our heart that sometimes are not in tandem with health decisions. The neurological symptoms were new at this instance, and a few scientists later in China confirmed that the new virus, or the Zika virus that was spreading in Brazil, had mutated, and the mutation allowed it to attack neural cells or neurons much more easily, and so was able to cause this kind of symptoms. Ebola is another case that you've heard about for a while, first detected in 1976, and the biggest outbreak being in West Africa, which caused nearly 30,000 cases, and a third of those died. And you know the ongoing outbreak now in Uganda. But there have been many outbreaks in the past. These usually cross over from fruit bats to wild animals, sometimes which amplify the infection. And then as somebody goes in to hunt the animals for meat, they get infected. Then they initiate a human-to-human transmission chain, which may amplify the infection now across humans without the need for animals. So this is an area where we have had several outbreaks, many of them in Congo. Fortunately, the villages in Congo are very remote and we don't usually get the urban cycle because many of them would need to travel there, and Ebola is severe, so more those who get sick tend to die before they get to these hospitals. But you can see the number of outbreaks that occurred are quite many. A smart virus is like herpes. It infects people and does not kill them normally. So it will infect very many people. A lot of you will have some antibodies of one herpes virus or the other. Could be EBV, it could be HSV, or whatever it is, because these viruses are able to spread effectively. But Ebola, which was killing, especially initially, 90% of people infected, would quickly burn out because this person is sick and they don't get to live long to transmit to others, or they are so sick they cannot even travel, and so people will stay away from them. But we see over time also the Ebola is getting less fatal. It's causing now less than 40% of deaths. So it's still maybe adapting and becoming more used to our bodies, so to speak. This was in Monrovia, and this photo is to highlight the need for a social conscious approach as you deal with outbreaks. Now, in Western Africa, when people died, healthcare workers would come and pick him, the person who has died, and bury him. And they're coming in these suits with a very inhumane touch, so to speak. And so people started hiding their dead. They were trying to avoid the rituals that people do when people die, either washing the body, lying next to the body, and what have you. But people realized that they were not comfortable with the measures the burial measures that were put in place. So eventually the healthcare workers had to sit down with the local leaders and come up with a good compromise where people would be able to report on the burials done, but it was done in a more humane manner, conscious of the social challenges. Because at some point people would say, I will not go to that hospital because if you have malaria and you go to the hospital, then you die from Ebola. Then it becomes a challenge. So it is good to be conscious of social practices and apply your interventions consciously. Otherwise, you'll end up with the interventions that are not adapted. It's like some people went somewhere to construct toilets, and then they built both ladies and toilets in the same space, and then it was impossible for the ladies there to use them. So it's you're trying to improve sanitation, but you don't really succeed. This is, again, same situation in West Africa. And you can see the similarities with COVID-19 initially, the early phases, even in Kenya. So how do we diagnose these infections? I'm going to look at your comments for a minute. Somebody saying those guys eat almost everything. Remember to have social intelligence because we also eat things that other people don't eat. Relationship with Spanish flu of the 1900s. SARS is different from influenza. You can actually draw a table and write 5 similarities between influenza and SARS and 5 differences. Okay, I don't see any question there, so I'll proceed. Now, open your minds. Diagnosis needs to be very broad. Keep in mind that you don't even know what the pathogen is. We are starting from there. Somebody has presented with that rash, you don't know what it is. So you need to keep in mind that, yes, if I test for example, flaviviruses, I don't know it's Zika, so I need a test that may be able to detect flaviviruses. And because we know, for example, flaviviruses cross-react, an ELISA that is able to detect dengue might also detect antibodies against Zika or yellow fever. So you can use that, and then if it's positive, you don't say it is dengue, then you can say, oh, this could be a flavivirus. If it's negative, then not much. And that is the same thing with immunofluorescence assays. And then you can then confirm with neutralization assays. Neutralization tend to be more specific. So you start broad with these elements that are cross-reacting, and then you know if you are targeting a certain group, it may be a good way to start if it's the only thing you can do, but it's not very, very reliable. You also then can test for nucleic acid PCR. In this instance, you may want to use the group consensus primers rather than using if you suspect it's Zika, for example, rather than using Zika primers, you can use primers for alpha viruses. For example, in Kenya, we tend to have yellow fever outbreaks. So instead of using a yellow fever specific PCR, you can first of all use a broad primer, which can detect all flaviviruses. And then after that, you confirm which one it is, either by Sanger sequencing or even whole genome sequencing, or even specific primers, which can be a second PCR. We saw the other day high throughput sequencing or next generation sequencing, as it's most frequently known. I'm using high throughput because the other day, as we discussed, we saw that you have both second generation or next generation and third generation now. Both of them can be used. And also virus isolation by cell culture. Now, the good thing with sequencing, for example, is that you can do unbiased or non-pathogen specific. Any pathogen in the sample will be detected, which is a good thing. And that I would say is my choice of test, because you are testing a sample, you don't know what it has. You have the ability to test it and detect anything that is in that sample. Is it blood, be it a swab, be it stool, be it urine. Very few tests will give you that. And further, you can then get the full genome of that virus or that pathogen, which will then help other things like the designing PCR primers, designing vaccines, because when you design a PCR and a vaccine, the sequence is very useful. Designing even antigens for putting in antigen tests, rapid tests. And then virus isolation needs to keep in mind safety. So you can do this only at maybe BSN 3 or 4, where the security is adequate, but also keep in mind that you need to use cell lines, different cell lines, because certain viruses, for example, will only grow in certain cell lines, be it a mosquito cell line for arboviruses or bat lung cells for a respiratory virus, and so on and so forth. So you can use several cell lines at once and see whether any of them grows the virus. A good one would also be electron microscopy, because you can inactivate the virus and then just visualize it. If it looks like a coronavirus, then you can get primers specifically for coronaviruses. If it looks like influenza virus, you can get primers specifically for influenza to confirm the virus, because electron microscope will show you the shape, it will not tell you the species. So keep an open mind when dealing with emerging and emerging infections, especially for diagnostics. Try and keep your assays as broad as possible, and then zero in after you confirm certain characteristics. For example, if I was able to induce hemagglutination using a respiratory sample from somebody with a respiratory infection, then I can zero in on viruses that cause hemagglutination. Challenges in combating ARIES are many. One is the unpredictability, which we discussed before. We also have the fact that there are so many pathogens. You've seen, you can't really say, you can't list all of them either. There are so many. You can't say you're going to have a test for all of them. Animal reservoirs, you cannot eliminate all animals. You say, let's go to Nairobi Park and kill all the rodents. It is not possible. And because of that reason, then we probably need to come up with innovative ways for the viruses that we know, like rabies, to try and vaccinate them. Maybe it can be done economically. Like people have tried giving bait to these animals, but the efficacy has been questioned. Lack of appropriate vaccines and antimicrobials. You saw initially when COVID started, and even other emerging pathogens like SARS and MERS, we did not have a vaccine or even an antimicrobial agent. So this becomes a challenge. At least for monkeypox, we had the vaccine for smallpox and the antimicrobials for smallpox. So try, even if you're not sure that especially the antivirals would work, the vaccine we knew would work. And so for this reason, you probably need to have a lot of research work ongoing so that it can quickly be targeted to a new challenge. And diagnosis, we saw takes time because the symptoms are not specific. The methods are also, you don't know which method to use. So you have to be creative and find out, how do I take advantage of what I have to try and get an idea what this pathogen could be. And then the capacity also becomes a challenge. Many labs dealing with patients out there will not have very highly trained staff, and even the experience may be limited. So we have challenges in the health systems. Mitigation will require political will because of budgets to fund all the things that are needed, including infrastructure, surveillance, human resource, and information. IT is very important for this so that you can fund information collection and sharing. You can imagine if we had apps and everybody reported every time they had a fever or a cough. That is called event-based surveillance. So every time there's a death or a flood, and you have a central collection server that then visualizes these areas and shows you in Kibera, there are a lot of people are reporting diarrhea as compared to last week. In Chiromo, there are a lot of people are reporting fever as compared to last week. This way, healthcare workers can actually target those places and find out what could be the issue, take a few samples and test and confirm. Because you can't test everybody in the country, that may not be feasible. But you can look at different ways of making your surveillance more effective. Capacity building from health workers, infrastructure in terms of facilities, labs, machines for testing. It will take a bit of funding, and that sometimes is a challenge. The other challenge we have now is who pays. The challenge I found as, say, working as a medical officer in different facilities is that you have a patient who comes to you, say the guy has what? Upper respiratory tract, as a sore throat. You have the option of sending him for a culture. The culture is, say, 2,000 shillings. But this guy only has 500 shillings to buy drugs. So you may opt to just prescribe the drugs for this guy and tell them if they don't get better, then come back. Many times, because it's a viral infection, they will get better. But you probably gave them antibiotics, which means you really didn't help them. So the problem there is who pays for that test. And if we can sort out, and I guess this is where universal healthcare comes in, if you can sort out who pays for that test that is 5,000 shillings, does it have to be paid out of pocket, or can it be paid through another way so that everybody who requires this test gets it? Then you'll find out that you have more information to guide your care. You know that out of 100 people who come with a sore throat, 90 of them have a viral infection, so I don't need to give them antibiotics. But now you end up treating blindly because you do not have the tools. And if you have them, the patients do not have the means to pay for them. Surveillance can take many forms. I encourage you to look at this. You can have what we call sentinel-based, where you have, say you choose one facility like Mbagathi and keep looking at it and see what is happening. You can have the event-based, which is basically reporting of different events by different people to a common system. There are currently a few systems on event-based that bring together human and animal health workers to report. And these are not necessarily healthcare workers. They could also be community volunteers who can do this. You also have the syndrome-based approach. This is my favorite because I'm more into diagnostics, where you get people presenting with fever, people presenting with upper influenza-like illness or upper respiratory tract infections, people presenting with diarrhea, and test them just to see if there are any new pathogens in circulation. So there are different ways of surveillance, and this will help us to. They're also disease-based. So for example, the government of Kenya collects information on measles, cholera, dengue on a regular basis. So every patient who comes to you with these diseases, the information is passed over to the ministry. Vaccination also helps where it is available. We saw the issue with measles, some people saying that the vaccine is not safe, so they stop taking, and then later a large part of the population is exposed and they get sick and they transmit to others. So vaccination is a big thing, and it's still very efficient. And then we fund research and development. One of the things that helped us get vaccines for COVID-19 very fast was because people had done work before on SARS-CoV and MERS-CoV. So those technologies were quickly shifted to SARS-CoV-2, and we were able to use that information to develop vaccines fairly fast, and even medications. So that is an important thing to do, because without R&D, then we will not be able to stay ahead of the curve of the emerging infections. There are other things like antimicrobial stewardship, where we encourage you not to use antibiotics unless they are indicated, and not to use broad spectrum antibiotics unless you have to. If a UTI can be treated with nitrofurantoin, don't give meropenem or another strong antibiotic, as people say. Vector control can help. If you are from Mombasa, next time you're walking around, look at the tires and how much water they carry. Every time you knock one of them, you will find a lot of Aedes mosquitoes. In 2018, I was collecting mosquitoes in Mombasa, and we learned that if we just go to anybody selling tires and look at those tires, we'll get a lot of these mosquitoes. And right now, dengue in Mombasa and chikungunya are almost endemic because of this availability of these vectors. Health education cannot be underestimated. I encourage all of you to look at messaging as a key part of your work to inform patients about different health issues. When a patient comes to you with a sore throat and they're insisting on antibiotics, take a few minutes to convince them and educate them that their sore throat is not, does not need antibiotics. Some will do, of course, not all of them. So take that moment to educate them, because many times you just want to appease your patient, especially working in the private sector. Let them get what they need, then you can move on and clear your queue. Don't be that guy. We also need to work on our warning signs and rapid response systems, where we are collecting data from different parts of the country, data from different systems, animal, weather. If we know there's going to be a flood, we can prepare early for what could happen. We know there could be cholera, there could be mosquitoes multiplying in that area. This will help us to react early, instead of be proactive rather than reacting after the event. International health regulations are also important. For example, we know yellow fever vaccination, reporting an outbreak when it occurs. You can't stop or hide information. For example, if we found a case of monkeypox and we need to report and we just kept quiet, then we will not be helping the global community to control it. And also global health surveillance networks, you can become part of those. We have in Kenya, at least for influenza, and also other infections like polio and whatnot. They are important and usually run by the WHO and now Africa CDC to keep abreast of where these outbreaks are occurring. The other thing I keep introducing to you is One Health approach. Please be ready to work with animal health experts and environmental health and ecologists so that you make your work more meaningful and more productive. There is also a new concept now called planetary health, which looks at different impacts of our human life on the Earth's natural systems and on our human health and all life on Earth, the things we do. And many times you can be overwhelmed and think that your actions are not important. If you look at, say, for example, climate change as a big thing that you cannot do anything about, then you lose hope and begin to think that you can't have an impact. But there are many small things that you realize we do that can make your impact on, say, for example, planetary health more positive. A lot of us may use vehicles for distances that you can walk, and that may not be useful. We also have issues about tree cover that some of us contribute to destroying. And all these are things you can positively or proactively work on, like tree cover, and so that you can trap more carbon in the trees, and also using less gas, because a lot of us use cars for travel, and that is probably the biggest contributor to global warming. So think about these things. Don't just let them be out there. Other people are talking about them and you have no idea what they mean, because they impact your health and that of your patients. So here's a question as we finish. I would like to know if emerging infections are restricted to the tropics. Are they present with distinct characteristics? Oh, do they present with distinct characteristics? And can they be recognized easily because they are new? Or are they often contracted from animals? So please post your answer in the chat and I can let you guys go for lunch. Thank you very much for your attention. I can see a lot of people are choosing D. One guy chose E. He must be thinking outside the box. I don't see any wrong answers. So yes, the correct answer is that they are often contracted from animals. So keep your head up. Every time you see a patient, be sure you are protected. Don't just go doing examinations without gloves, or where indicated, you need to have your masks on and even your gowns, so that you don't become the doctor who gets infected first by Ebola in Kenya. Thank you very much. If you have more questions, post them in the chat. I'll answer them in the next 2 or 3 minutes. Then I'll let you guys go for your prayers and lunch. Now, I have to say this, by Friday, we'll have 2 sessions with me because I will not be available next week. So one of my sessions on antiviral agents will be on Friday afternoon, and then Dr. Langat will take my sessions next week to cover the virology methods. So on Friday, we meet in the morning for the usual topic that is in the timetable, and in the afternoon, we'll meet for antiviral agents. Okay, so I see here a message on a question on, is vaccination the main strategy? No, it's not the main strategy because a lot of the infections do not have, you don't have a vaccine. So you'll not be able to use vaccines for everything. But where a vaccine is available, remember there's also re-emerging of infections. So that is used for preventing re-emergence. So yes, that is important to note that vaccination is not the main strategy for preventing emerging diseases. Is abortion the answer for pregnant ladies with Zika? Not necessarily. You have to take each case as it is and even probably do imaging to see if, for example, a child has severe, what is it called, severe congenital abnormalities. You make that decision as a clinician at that point. And also the parent. The parent can decide to carry the pregnancy to term, or they can decide to terminate. Okay, so there are no straight jacket answers. Many of us try to say no abortion. Some people will say do abortion, but there's no straight jacket answer to these things. You have to consider each case as it comes without being judgmental and without applying your values on other people's health. You need to use their values, not just yours alone. If you cannot do it, then you recommend a clinician who you feel will be comfortable with it. Okay, so I would like to stop there. If there are no more questions or issues, I'm happy to let you guys take the rest of the time. Thank you very much.
Thank you.